Arithmetic series. So we've been looking at sequences. Sequences is legit just the pattern of numbers. Series is what happens when you add them up, okay? So it's the expression for the sum of the terms in a sequence. Finite sequences have terms that you can count individually. Infinite sequences continue without end. You indicate it with an ellipsis. Do y'all know what an ellipsis is? Yes, little dot, dot, dot. There we go. So this is a finite series. It ends. It has a beginning and an end. This is an infinite series. This little guy says, keep going. All right. Finite sequence, infinite sequence. So you'll notice the sequence just has a list of numbers. The series has this little plus sign in between it because it's the sum of. All right, the sum of. Use the finite sequence, write the related series, then evaluate the series. Okay, seriously. I mean, I'm not actually going to make you do this because. So 2 plus 11 plus 20 plus 29, seriously. And then they want you to add it up. That's the difference between a sequence and a series. Sequence is just the list of numbers. That's what they gave you. Series is the summation. Evaluate would be add them up. An arithmetic series is a series whose terms form an arithmetic sequence. When a sequence has many terms, or when you know only the first and last term, you can use this formula to evaluate. I think I have him right here. And there we go. Gauss. So, grade. You figured out that we have these pairs of numbers that happen in a series. And he was like, oh, look, that's 101. And that's 101. And that's 101. And if I have 100 of them and they pair up, that means I have 50, which is 5,050. Little Gauss came up with that. The terms here, for in this case, 1 to 100, 100 being the number of terms he has, 100 over 2. That's why he multiplied by 50. And then the first term added to the last term here, 1 plus 100. So 101 times 100 over 50. And that's how we added up 1 to 100 so very quickly. And he's credited with this particular series. But this is the series you have to memorize. Finite arithmetic series. Ace of 1 all the way to ace of n. Ace of 1 is the first term. Ace of n is the last term. And n is the number of terms that you have. And so instead of saying 1 plus 2 plus 3 plus 4, ellipsis, all the way to 100, you can just say, well, I'm going to have 100 terms. My first term is going to be 1. My last term is going to be 100. And that will always, always add up to your arithmetic series. Embroidery, such as cross-stitch, frequently decorates linen tables. All right. And clothing. Yes. Although it was originally used to strengthen and repair woven fabric, several rows of cross stitch make up the green roof. Find the total number of green cross stitches in the roof. All right, so row 1, row 3, and row 5. I am not going to add all those up, but we're going to take his word for it. The first row has 5. The last row has 13. So we're just going to go with this because the worst part of cross stitch is actually counting them, by the way. So the first row has 5 in it. The last row has, according to them, 13 in it. Okay. And then the total number of rows is 5. So we have total number of rows over 2. So the pattern here, which they don't even talk about the pattern, but the pattern is arithmetic. Row 1, row 3, row 5. So we know we have 5 ends altogether. 1, 2, 3, 4, 5. That's where we get this one from. This is part of your formula. 2. Ace of 1, that is your first term. Ace of 5, in this case, that's your last term. And so you would add those up and get 45. 18 times 5 over 2, 45. That's how many stitches would be in that series, arithmetic series. All right. Look at the, so if I know my common difference is 2, what's the easiest way to find my 14th term? Remember my explicit formula for an arithmetic. So my explicit formula for arithmetic says take your first one, add it to your common difference times n minus 1, right? So if I'm doing this for my 14th term, I'm going to take this formula right here, and I am going to use it to do this piece right of that. Suppose the pattern extends to 14 rows of cross stitch. Find the 14th term of the sequence. Use the formula to find the value of the series. Okay, so here. So I'm going to say, well, here's my explicit formula. I want the 14th term. My first term was what? What was my first term? 5. 2 times what? 14 minus 1, which is 13. All right. So if I wanted my 14th term, what's it going to be?
It's going to be 31.
31. So my 14th term is 31. All right. Now they want me to add up every single stitch that I now have if my roof extended to that many rows. All right. So now I can go back. How many rows now am I going to have? 14 rows. So that's going to be my n. So now I'm doing, by the way, it's notated this way, summation of the 14 rows, okay? The summation of the 14 rows is going to be the 14 over 2. My first term is still 5. Now my last term is what?
31.
It's 31. All right. And so then I'm going to do that. 36 over 2, right? And then times 14. 252 stitches. You can use the summation symbol that looks like an E. It's actually a capital epsilon to write a series. Then you can use limits to indicate how many terms you are adding. Limits are the least and greatest integral values of n. You have a lower limit and an upper limit. Lower limit is the number that you start on for this series, and upper limit is the where you end. Then you have an explicit formula, just like we did with our cross stitching, right? If I had simplified that, so I had what, 5 plus 2n minus 1. If I had simplified this, right, I would have done this, 5 plus 2n minus 5, and minus 2, not 5. Then I would have had 2n plus 3, and that would be my explicit, right? Simplified explicit. So when you do this summation notation here, you're going to have this little symbol here, right? Your summation symbol. Your starting, this is not your starting number. This is your starting term, first term. This doesn't mean your first term is 1. It means this is first term that you're starting with, and you're ending with the third term, okay? Ace of 1 to ace of 3. And then they give you your explicit formula here, 5n plus 1. So if I wanted to find my first term, I would plug a 1 in there. 5 times 1 plus 1. What is my first term here? What's my ace of 1? If this is my explicit formula, what's my first term?
6.
There we go, 6. All right. What's my third term? 16.
Wait, okay, yeah. No.
I mean, 3 terms doing a summation, add 1, 2, 3 potentially. But if this were the first 30 terms, you can see we're using the Gauss formula would be better, right? So if I'm adding 3 terms, very simple. If I'm adding 15 terms, first and last term over 2 times the number of terms, right? And so there's going to be a situation where it's easier to do it one way or the other. So summation notation. Use summation notation to write this series, all right? So in order to have summation notation, you need the explicit formula, all right? Explicit formula. So remember explicit formula for arithmetic. We just did it. Ace of n equals ace of 1 plus d times n minus 1, all right? So first explicit formula, what's my first term in this particular?
3.
Yeah, so it's 3. What's my common difference? Also 3. So then I want to make this explicit formula simplified. What is it?
3 plus 3
plus 6.
Right, which looks like what?
3n.
3n. Right? Your threes will cancel. That's my explicit. So then I'm going to do this summation here. I am going to do my little symbol. I'm going to say we're starting with our first term. All right. We're going to, it says how many terms? So my upper bound is 33. And my explicit formula is 3n. All right. That is summation notation for this particular series. Now, how would I then calculate that? Well, I could use my formula. All right, so if I wanted to actually calculate what that is, let's say I wanted the actual summation, I would say n over 2, ace of 1 plus ace of n. All right? Yes? So n, how many terms do I have here?
33.
So I'm saying the summation of 33 terms. What's my first term? 3. What's my last term? That's my last n. What's my last term? It's 99, right? It's explicit formula. Explicit formula. All right? And then I can actually calculate that out if I wanted to do the actual summation of this. Right? So if they ask for the summation notation, that's your little symbol. If they tell you to then actually calculate the series, actually do the summation, then you would actually do your formula. All right? Write the summation notation needed for each of these series. They just want you to write it out. You don't have to actually calculate it. So just write the summation for both of these two, A and B. Using it. So you can also be handed this notation. Find the number of terms. Well, you start with 1 and go to 3. I will say, when you're finding the number of terms in the series, you have to subtract and add another one. Why? Well, I started with 3. What's 3 minus 1?
2.
But how many terms are in this series?
3.
You didn't count your starting number, right? So if you just subtract, I'm saying this because if it goes from like 2 to 15, many of you are going to say there's 13 in the series, and there's not. So when you subtract, like 5 minus 1, that's 4. But when you go from 1 to 5, 1, 2, 3, 4, 5, that's 5. Does that make sense? So if they're asking how many terms, you are also counting the starting term. So you basically have to subtract your upper bound minus your lower bound plus 1. Okay? It's easy when there's 3, but when they don't start with 1, then all of a sudden you're subtracting out and you forget to add that 1 back in. So yes, there are 3 terms. The first and last term, how do I find the first and last term? Plug it in. What is my first term here? We did this just a minute ago. My first term is, we just did it, 6. My last term is 16. Evaluate. You can do this a couple of ways. I already have my first and my last term. So honestly, I can just plug in my middle term, which is going to be, right? And I can add. Does that make sense? Or you could do your summation if you wanted to. Either way, when it's only 3 terms, you might as well just add them. Okay, make sense? So let's look at this guy. Evaluate the series. How many terms am I going to have here? Oh, I'm going to have 10. How many terms am I going to have here? I'm going to have 4. But how many terms am I going to have here? 4. I started at 2 and went to 5. Okay. Does everybody see why you have to add the 1 back in? Right? Make sense? All right.